Hi, today we'll be solving the problem for polynomials and factorization exercise 2.4 for the problems of factor theorem. So the first problem I'm solving, it is given as determine which of the following polynomials has x plus 1 as a factor. So I'm taking first bit as p of x is equals to x cube minus x square minus x plus 1, and it is given we have to find out whether x plus 1 is a factor. So g of x, I am taking x plus 1. Consider g of x is equals to 0, that implies x plus 1 is equals to 0, that implies x is equals to minus 1. So p of minus 1 will be equals to minus 1 whole cube minus of minus 1 whole square minus of minus 1 plus 1. So since the power is odd, minus remain as it is 1. Power is even, minus changes to plus, but minus into plus will gives me minus 1, minus into minus plus, and plus 1, again this plus 1. So minus 2 plus 2 will give me 0. Therefore I can say that g of x is a factor of p of x. That is, x plus 1 is a factor of x cube minus x square minus x plus 1. Now I'll see the next problem based on this. Now I'll see the third bit, that is I'm considering p of x is equals to x to the power 4 plus 2x cube plus 2x square plus x plus 1, and g of x as x plus 1. So consider g of x is equals to 0, that implies x plus 1 is equals to 0, that implies x is equals to minus 1. So p of minus 1 is equals to minus 1 whole to the power 4 plus 2 into minus 1 whole cube plus 2 into minus 1 whole square plus of minus 1 plus 1. So this, since the power is even, minus changes to plus, so 1 will be remaining. Power is odd, minus remain as it is, minus into plus is minus, 2 ones are 2. Power is even, so minus changes to plus, plus into plus is plus, 2 1 times 2, plus into minus minus, 1 as it is, plus 1. Plus 1 minus 1 cancels, plus 2 minus 2 cancels, so answer will be 1. Therefore g of x is not a factor of p of x. Whenever we say a number is a factor of the other number, then the remainder should be 0. So here we are not getting the remainder as 0. So that is why we can say that g of x is not a factor of p of x. That is, x plus 1 is not a factor of x to the power 4 plus 2x cube plus 2x square plus x plus 1. Now I'll see the next problem, next bit, that is fourth bit. So p of x I am taking as x cube. First problem, fourth bit, x cube minus x square minus of 3 minus root 3 into x plus root 3. So g of x I am considering as x plus 1. Consider g of x is equals to 0, x plus 1 is equals to 0, that implies x is equals to minus 1. So p of minus 1 will be equals to minus 1 whole cube minus of minus 1 whole square minus of 3 minus root 3 into minus 1 plus root 3. So since the power is odd, minus 1 remain as it is, minus 1. Power is even, minus 1 changes to plus, so but plus into minus will give you minus 1. Here odd, minus into minus plus, plus 1 into 3 plus 3 plus into minus minus, 1 into root 3 is root 3 and plus root 3. So here you see what happens. Minus root 3 plus 3 gets cancelled. Minus 1 minus 2 and plus 3. The answer is 1. Therefore, g of x is not a factor of p of x. Hope I answered the question. Now I am solving second problem, fifth bit. So f of x is given as 4x cube plus 20x square plus 33x plus 18, and g of x is given as 2x plus 3, and is asking to find whether g of x is a factor of f of x or no. So I am supposing that g of x is equals to 0. So our g of x is 2x plus 3. That implies 2x plus 3 is equals to 0. That implies 2x is equals to minus 3. I am transposing this 3 to minus 3. That implies x is equals to minus 3 by 2. So now f of minus 3 by 2 will be equals to 4 into minus 3 by 2 whole cube plus 20 into minus 3 by 2 whole square plus 33 into minus 3 by 2 plus 18. Let me check whether I wrote it correct or not. 4x cube plus 20x square plus 33x plus 18, 2x plus 3. Okay. So now this gives me 4. Since the power is odd, minus 3 means as it is. 3 whole cube means 3 into 3 into 3. 3 3s are 9, 9 3s are 27. 2 whole cube means 2 into 2 into 2, that is 8. Plus 20 into power is even, minus changes to plus. 3 square, 3 into 3, 9. 2 square, 2 into 2, 4. This becomes plus into minus, minus 99 by 2 plus 18. Okay, now so 4 1 times, 4 2 times, and this is 2 10 times, 2 2 times. I am keeping the denominator as 2, so this becomes minus 27 by 2 plus 90 by 2 minus 99 by 2 plus 18 by 1 into 2 into 2. I am making them to like fractions. Like fractions having the same denominator. So my denominator will be 2. LCM will be 2. So here I have minus 27 plus 90 minus 99 plus 36. Now, so you can add them. What happens? This will become minus 99 minus 27. 9 plus 7 will be 16. 9 10 12 minus 126 plus 0 plus 6 is 6, and 9 plus 3 is 12 by 2, that is equals to 0 by 2. Minus 26 plus minus 126 plus 126 will become 0 by 2. 0 by any number is 0. Therefore we can say, therefore g of x is a factor of f of x. Hope I answered the question. For this exercise, third and fourth problem both are same. So I'll solve the fourth problem. You can understand both the problems. Okay. So fourth problem is given as show that x plus 4 and x minus 3 comma x minus 7 are factors of x cube minus 6x square minus 19x plus 84. X cube minus 6x square minus 19x plus 84. So first I'll consider f of x is equals to x cube minus 6x square minus 19x plus 84, and first g of x I am taking as x plus 4. Consider g of x is equals to 0, that implies x plus 4 is equals to 0, that implies x is equals to minus 4. Transposing plus 4 to the other side, which gives me minus 4. So f of minus 4 will be equals to minus 4 whole cube, in this one minus 4 whole cube minus 6 into minus 4 whole square minus 19 into minus 4 plus 84. Since the power is odd, minus remain as it is. 4 into 4 into 4 will gives me 64. Power is even, minus becomes plus, but minus into plus will be minus. 4 square means 16. 16 into 6 will be 96. Minus into minus plus. 4 nines are 36, 76, and this is also plus 84. Now see this, these two are with my negative sign and these two are with positive sign. This becomes 10, 160 minus 160, and this becomes 10. 6 plus 4 is 10, carry 1, 8 plus 1 9, 9 plus 7 6, 160, which is equals to 0. So therefore I can say g of x is a factor of f of x, that is x plus 4 is a factor of f of x. Now we'll solve next one in a similar way, taking x minus 3. The second bit I am taking as x minus 3. Now see what happens here. If I remove this, I am taking x minus 3. So this is minus 3. So this will be minus 3. When it is transposed, it will be plus 3. So wherever it is minus 4, I have to change as 3. Minus 4 will be changed to 3. Minus 4 will be changed to 3. So this whole will change. So sorry, here also I have to write as 3. So this gives me 3 cube means 3 3s are 9, 9 3s are 27, minus 3 3s are 9, 9 into 6 is 54, minus 3 9s are 27, and so this will be 57 plus 84. So 27 plus 84, 7 plus 4 will gives me 11, 8 plus 2 is 10 plus 1 11, and you add this, will get the same. 7 plus 4 11, 5 plus 5 10, 10 plus 1 11. 111 minus 111 will be 0. Therefore I can say g of x is a factor of f of x. So I hope you understood that x minus 3 is also a factor of x cube minus 6x square minus 19x plus 84, since we are getting the remainder as 0. Now we'll see one more, that is the last one, x minus 7. So I have to erase this. For x minus 7, so this whole I have to erase, this whole I have to erase. I don't know whether it is a factor or no, so I have to erase this all. So now x minus 7, x is equals to 7. So this gives me 7 cube, right, perfectly 7 cube, 7 square, 7. So f of 7, which is equals to 7 into 7 is 49, and 49 into 7, 7 9 is 63, 7 4s are 28. So 28 plus 6 will gives me 34. So this will be 343 minus 7 7s are 49, 49 into 6, 6 9s are 54, 24 29. So So this gives me 294 minus 7 and the 63, 133 plus 84. 84 plus 343. So 3 plus 4 is 7, this 3 and this 4 is 7. 4 plus 8 is 12, carry 1, 3 plus 1, 4. Now this 4 plus 3 minus will come, 4 plus 3 is 7, and 9 plus 3 will gives me 12, 2, 3, 4. 427 minus 427 is 0. So therefore here also I can say g of x is a factor of f of x. So all the three, that is x plus 4 and x minus 3 and x minus 7, are factors of x cube minus 6x square minus 19x plus 84. Hope I answered the question. Fifth problem is given as if both x minus 2 and x minus 1 by 2 are factors of p x square plus 5x plus r, show that p is equals to r. So here first we will see what we'll get when we take x minus 2 as a factor. It is said it is a factor. It is given that x minus 2 is a factor if both x minus 2 and x minus 2 and x minus 1 by 2 are factor. It means the answer should be 0. So p of x I am taking as take this as f of x. Solution: f of x is equals to px square plus 5x plus r, and g of x I am taking as x minus 2. That implies x minus 2 is equals to 0, or you can say g of x, consider g of x is equals to 0. That implies x minus 2 is equals to 0, x is equals to 2. Now p of 2, that is equals to p into 2 square plus 5 into 2 plus r. I am substituting the value of x as p in this expression. Okay, so this gives me 4p plus 10 plus r. This is r. So 4p plus r plus 10. Okay, so but p of 2 is equal to 0. That implies 4p plus r plus 10 is equal to 0, or 4p plus r is equal to minus 10. Now we'll see the other part. F of x is equals to px square plus 5x plus r, and g of x is equals to x minus 1 by 2. So consider g of x is equals to 0. That implies x minus 1 by 2 is equals to 0, x is equals to 1 by 2. So now f of 1 by 2 will be equals to p into 1 by 2 whole square. I am substituting here value of x as 1 by 2 plus 5 into 1 by 2 plus r. Okay, so now this will be equals to p into 1 by 4. 1 square is 1, 2 square means 4 plus 5 by 2 plus r. Now here this will be equals to p by 4 plus 5 by 2 plus r, but p of 1 by 2 is equals to 0. That implies p by 4 plus 5 by 2 plus r is equals to 0. If I multiply by 4, 4 into p by 4 plus 4 into 5 by 2 plus 4 into r is equals to 4 into 0. So that happens 4 1 times 4 1 times, 2 1 times 2 2 times. So I'm getting this as P plus 2 into 5 is 10 plus 4R is equals to 4 zeros are 0. So this gives me P plus 4R is equals to minus 10. Take this as 2, this as 1. So I'll be erasing this question here. I'll erase from here. So now from 1 and 2, from 1 and 2, see the RHS of 1 is minus 10, RHS of 2 is also minus 10. So I'll have 4P plus R is equals to P plus 4R. Right? So we will have, I'll bring all together, 4P plus R minus P minus 4R is equals to 0. 4P minus P, 3P, and minus 3R is equals to 0. So this gives me 3P is equals to 3R. I'm transposing this to right hand side. 3 gets cancelled. Therefore P is equals to R. Hope I solved the question. Now the sixth problem, if x square minus 1 is a factor of a x to the power 4 plus b x cube plus c x square plus dx plus e, show that a plus c plus e is equals to b plus d is equals to 0. So I'll take this as p of x. P of x is equals to a x to the power 4 plus b x to the power 3 plus c x to the power 2 plus dx plus e, and g of x is equals to x square minus 1. Consider g of x is equals to 0. So now x square minus 1 is equals to 0, x square is equals to 1, and x is equals to plus or minus root of 1, which is equals to plus or minus 1. Okay, so I'll take this as first p of 1, which is equals to a into 1 to the power 4 plus b into 1 to the power 3 plus c into 1 to the power 2 plus d into 1 plus e. So this is equals to a 1 to the power 4 is 1, a into 1 is 1, 1 to the power 3 is 1, b into 1 is b, plus 1 to the power 2 is 1, 1 into c is c, plus d into 1 is d, plus e. So I got this one. Okay. Since p of 1 is equals to 0, that implies a plus b plus c plus d plus e is equals to 0. Take this as 1. Now p of minus 1, that is equals to a into minus 1 to the power 4 plus b into minus 1 to the power 3 plus c into, I'll write it, c into minus 1 to the power 2 plus d into minus 1 plus e. So this gives me power even, minus goes, so a remains a as it is. Power is odd, minus remain as it is, minus into plus minus, b b into 1 is b. Even power minus plus becomes plus, so it will be plus into plus plus, c1 is c minus d plus e. Since p of e, p of minus 1 is equals to 0, since we said that x square minus 1 is a factor, so x minus 1 is a factor, x plus 1 is a factor. So that implies a minus b plus c minus d plus e is equals to 0. So that implies a plus c plus e is equals to, I am transposing b, so it will plus b plus d. So here we have shown, this is the second one. So in place of a plus b plus c in first one, if I replace it with b plus d, then I can see that, see, I am writing here, substitute 2 in 1. So we'll get this as, see, I am writing this as a plus c plus e and plus b plus d is equals to 0. A, B, C, D, E. Okay, now I have a plus b plus e is given as b plus d. So I am substituting second, b plus d. This is our b plus d from 2 plus b plus d. I write here from equation 2. Okay, so b plus d, so 2b plus 2d is equals to 0. So take 2 common, I'll have b plus d is equals to 0. So 2 cross multiply, when I cross multiply it will be 0 by 2. So what I'll get is b plus d 0 by 2, that is b plus d is equals to 0. So I proved that b plus d is equals to 0. Now I have to prove that a plus c plus e is also equals to 0. So now see, I'll write here from 1 and 2, or so I'll write like this, substitute 2 in 1. Substitute b plus d is equals to a plus c plus e in 1. So this can be written as, so our first equation is a plus b plus c plus d plus e is equals to 0. So in place of b and d, this a plus c plus e as it is, and b plus d I am writing again as a plus c plus e is equals to 0. So it will be 2a plus 2c plus 2e is equals to 0. Take 2 common, I'll have a plus c plus e is equals to 0. That implies a plus c plus e is equals to 0 by 2. That implies a plus c plus e is equals to 0. 0 by any number is 0. Therefore, I proved that a plus c plus e is equals to b plus d is equals to 0. This is what they asked me to prove. Hence I proved the problem. Seventh problem is factorize. Factorize. First bit is given as x cube minus 2x square minus x plus 2. Here what I'll do is, see the constant term 2. I'll see all the factors of 2. All factors of 2 are minus 1 plus 1 and minus 2 plus 2. So first I'll see with plus 1. By trial method, I'll take g of x is equals to x. I'll write put x is equals to 1. So this I'm taking as p of x is equals to x cube minus 2x square minus x plus 2. So p of 1 is equals to 1 cube minus 2 into 1 square minus 1 plus 2. 1 cube means 1, minus 2 minus 1 plus 2. Minus 2 plus 2 minus 1 plus 1 cancels. Therefore p of 1 is a factor of p of x. That is, 1 is a factor of p of x. That implies 1 means I can write this as x minus 1 is a factor of p of x. So I'll find out the other. I'll show you one method by synthetic division method. What I have to do is here is I'll take x is equals to 1 and I'll take all the coefficients here. What I have, the coefficient of x cube 1, coefficient of x square minus 2, coefficient of x minus 1 and this constant 2. And below this one I'll write 0 and I will add them. 1 plus 0 is 1. Now multiply this value of x with this remainder. 1 into 1 is 1. Now again minus 2 plus 1 will give me minus 1. Minus 1 into minus 1 will give me minus 1. Minus 1 minus 1 will be minus 2. Minus 2 into 1 will give me minus 2. Now plus 2 minus 2 will become 0. So this I can write as a quadratic equation, that is minus 2 minus 1 means x and this will be x square. So I got one factor as x minus 1. The other factor is, so I can write here p of x is equals to x minus 1 into x square minus x minus 2. Now I'll find out the factors of x square minus x minus 2. X square minus x minus 2. Square term should be multiplied with constant. So this gives me minus 2x square and 2x into 2x. Sorry, 2x into x will give me 2x square, and even 2x minus x will give me the middle term. So what is the sign of the middle term? Minus. So it should be given to the bigger factor. Since I am subtracting, the other factor should be with plus sign. Got it? So x square will remain as it is. The middle term is split as minus 2x plus x minus 2. So in this 2 x is common, x minus 2, and in this 2 nothing common, so I'll take 1 common. Again it will be x minus 2. See, again in this 2 term x minus 2 is common. So when x minus 2 goes, x is remaining. X minus 2 goes, plus 1 is remaining. Therefore, factors of p of x is equals to x minus 1 into x minus 2 into x plus 1. This is how you have to solve the remaining problems as well. Hope I answered the question.